When does a home lab stop being a hobby and become infrastructure you actually rely on? This 3-node cluster crossed that line, and getting there takes more than just uptime. This is a lesson in operating a production-grade Kubernetes cluster, assessing its maturity, mastering the operational command toolkit, and building a safe operations dashboard. Let's start with maturity. The cluster in question is a 3-node K3s deployment, and it scores roughly 9.3 out of 10. That's not a home lab anymore. Area by area, the strengths are broad. Control plane high availability, worker scheduling, and distributed storage with Longhorn are all excellent. Backups are mature too. Automated RESTIC backups, PostgreSQL dump automation, and etcd snapshots. Add TLS and ingress automation, plus a private container registry on GHCR. The remaining gaps are honest ones. Disaster recovery is good, but off-site backup is still pending. Monitoring could be expanded, auto-scaling is a future enhancement, and GitOps can be strengthened. The health metrics tell the story of a stable system. All 3 nodes, ready. 128 pods running without failures, and 38 of 38 Longhorn volumes healthy. Backups back this up. Successful restick runs, automated PostgreSQL dumps, and regular etcd snapshots. On paper and in practice, this cluster is healthy. But there's one critical blocker. Today, the backup chain runs from applications, through Longhorn, through RESTIC, all onto the same infrastructure. Once Backblaze B2 is configured, the chain extends off-site. That single step protects against catastrophic site loss, hardware theft, fire, or major electrical damage. After B2, 3 priorities follow. First, monitoring and alerting with Prometheus, Grafana, and Alert Manager, sending notifications over email, Slack, or Discord. Second, disaster recovery drills. Restore Longhorn volumes into a fresh cluster. Restore PostgreSQL from dumps. Restore etcd snapshots. And verify the entire recovery process end-to-end. Third, capacity planning. Track CPU and RAM utilization, storage growth, Longhorn replica health, and network throughput so you see problems before they arrive. The takeaway is clear. This is a platform, high availability Kubernetes, distributed storage, automated backups, TLS, production ingress, and infrastructure that keeps running after node failures. It frees you to operate applications instead of rebuilding the platform. Now, the operational toolkit. A complete day 2 setup covers roughly 60 command patterns, but don't memorize them. Learn the categories and the philosophy behind them. Start with health checks, a full sweep of nodes, pods, deployments, PVCs, storage classes, ingress, and recent events. The daily trick: filter pods by phase not running and not succeeded. No output means all is well. Node operations. Inspect a node, check its taints and labels, and drain it safely for maintenance. Cordon first, then drain, ignoring daemon sets. And never drain 2 control plane nodes at once. Uncordon to bring it back. Control plane care. Check the K3 service and its journal on each node, restarting only one at a time. Verify embedded etcdd with Redizo and Levez, and take a manual snapshot before any risky change. Application operations. Inspect resources in a namespace. Follow pod logs including the previous crashed container, describe failing pods, and find the unhealthy ones. Crash loop back off, image pull back off, pending, evicted. Then recover safely. Restart deployments with rollout status verification. Roll back with rollout undo to a specific revision if needed, and scale replicas up or down. Networking and TLS. Check services and endpoints. Test a service from inside the cluster with a throwaway curl pod. Run DNS tests, and inspect Trafic and Core DNS. Verify public sites with curl. Check Cert Manager for its cluster issuers, certificates, and any that aren't ready. And read certificate expiry directly off the live endpoint with OpenCL. Storage. Check Longhorn system health across nodes, volumes, replicas, and robustness. Watch node capacity. Map PVCs to volumes. Verify recurring backup jobs and targets. And scan manager logs for degraded or faulted states. The backup chain. Inspect the Restic repository, snapshots, stats, and an integrity check. Run manual backups, verify the system timer, and critically, test a restore into a temporary directory. Never over live data. For databases, check dump freshness by listing dumps from the last 24 hours, and manually dump with pg-john dump piped through gzip, then verify integrity. Safety practices tie it together. Always show your kubectl context before changing anything. Preview changes with kubectl diff, and validate YAML with a server-side dry run before you apply. Keep an emergency overview one-liner that shows nodes, abnormal pods, warning events, volume health, certificates, and resource usage in a single shot, plus a daily morning status that includes backup timers and the latest etcd snapshots. And finally, the danger list, commands never to run casually, deleting namespaces, PVCs, PVs, or nodes, wiping the K3s or Longhorn data directories. K3s uninstall, bulk manifest deletes, and restick forget with prune. These can permanently destroy workloads, data, snapshots, or backups. So, should you build a user interface for all this? Yes, but not as a generic Kubernetes dashboard. Mature options already exist, and reinventing them is wasted effort. Consider the field. Headlamp is a web UI for resources, logs, metrics, scaling, YAML editing, and RBAC with plugins running inside the cluster. Rancher suits multi-cluster admin. Lens is a desktop IDE. Portainer abstracts too much, and Longhorn already has its own UI. The recommendation: install Headlamp for detailed Kubernetes administration. Then build a smaller custom panel for what's unique here. Because existing tools understand Kubernetes, but they don't understand your whole backup chain. The custom panel would show 3-node health, failed pods, Longhorn volume health, the latest restick backup, PostgreSQL dump freshness, the latest etcd snapshot per node, certificate expiration, website checks, B2 status, and node disk, CPU, and memory. Add safe action buttons, restart, scale, cordon, drain, and run backups, each with a complete audit history. But now comes the most important design decision, and it's the security lesson. Never let the UI execute arbitrary shell commands, no kubectl pass-through, no sudo, and no general-purpose terminal exposed through a browser. That is the line you do not cross. Instead, implement predefined validated operations. Restart, scale, cordon, drain, run backups, create etcd snapshots, test websites, view logs, each with RBAC permissions, confirmation for destructive actions, input validation, timeouts, captured output, audit logging, and a read-only mode. Architecturally, a React or Next.js UI in front of a management API that uses the official Kubernetes client libraries, never shelling out to kubectl, plus Longhorn CRDs, a backup status collector, a node agent for host-level tasks, and an audit database. Get this right, and you've built a real product, a cluster operations panel, rather than a copy of a dashboard that already exists. Let's recap. Maturity means honest assessment and closing the off-site gap. The toolkit is about categories, safety, and knowing the danger list. And a UI should extend, not clone, with predefined, audited, never arbitrary operations. If this helped you think about your own infrastructure like a platform, subscribe for more operations and security lessons. and drop a comment on what you'd put in your custom ops panel.